My name is Emily Stolfo. I work for MongoDB, where I co-maintain the Ruby driver to the database. It's the Mongo and Bison gems, if you've used the Ruby driver at all. And I'm going to talk about gem API design for gem authors and users. Even if you're not a gem author, this will cover a bunch of concepts that are relevant to software engineering in general as well. So why am I talking about this? Well, I do co-maintain this Ruby driver at MongoDB, but I also realized that many of us have become gem authors through one of two ways. One way we could have become a gem author is by working on a Rails application at our company and realizing over the course of time that our application has become unwieldy, really complex, trying to do too many things, and we've decided as a team to break up our application into multiple services and tie everything together with a gem. Put all of the business logic in one place, centralize all of our data models, and maintain this gem internally at our company along with our colleagues. So that's one way. The other way is by adopting a gem and becoming a gem maintainer, or by building a gem, open sourcing it, and becoming a gem author or open source gem maintainer. So the point of this, though, is that there was a transition at some point. You were a web developer before, and then you transitioned into becoming a gem maintainer, a gem author. And before, your code was serving people who were using a browser and a mouse. So it was good enough that your code worked. Didn't really matter what you called your variables. If you wanted to use curse words, that was fine as well. It was sort of funny. But now it's not the same thing. Your code now serves other developers. It serves other people who are looking to your gem to provide some kind of functionality in their own applications. And these other developers are your future self, your future colleagues, your current colleagues, open source users, regardless of whether you're a gem author inside a company and the gem you're working on is proprietary or it's an open source gem, the things you need to think about are the same. And they're not quite the same thing you need to think about as a web developer. So my personal story is that I was a Rails developer about 2 years ago, and we had this web application that was serving up pages to customers. They were buying things on our site. But this Rails application was also serving us internally. It was helping our third-party vendors print things and move them around. It was helping us to run analytics on user behavior. It was helping us run analytics on financial data. It was helping us manage inventory. It was doing all of these things all in one application. And it was super complex and just really horrible to maintain. So as I said, along with a lot of you, I'm sure, we split it up into two different applications. And we created a gem that had all of the business logic, all of the data models in one place. And then we maintained it amongst ourselves and managed dependencies and versioning and all of that. And the other transition that I went through was that as I moved on from being a Rails developer to working at MongoDB, where I now co-maintain this Mongo and Bison gem, I realized that it's not quite the same thing, in the same way that it wasn't quite the same thing maintaining this gem at my past company. I need to think about users. I need to think about other developers like myself using my code. This is a gem, a quote from someone commenting on a gem that a lot of people use. It's really popular. I didn't want to put the gem on the spot and say it sucks, but the point here is that this gem is used by, I'm sure, majority of people in this room. And someone said, I love the contribution to open source, but it's not very obvious what's going on when I look at the code. It's an example of poor OOP design, poor documentation. It's sort of a black box. It seems like there's a lot of magic. I don't really know what's going on. But as I said, I appreciate the contribution to open source. So people will appreciate your contributions. But if you want your gem to be used, if you want people to contribute to your gem, if you want it to be this living, breathing thing that people like and use, you need to think about something beyond just, does my code work, do my tests pass? So gem API design is UX design, is user experience design. It's about users. And that's the fundamental difference between writing a web application and maintaining a library that other people use. So why is it important to think about things as user experience tasks? Or why is user experience important? So there was something called the UX Fund experiment that was run in 2006 to 2007 by a design firm in Toronto. And what they did was they made up a list of 10 companies that they deemed to have superior user experiences. These are companies like Google, Apple, JetBlue, all of the companies that you probably think of when you think of a great user experience. And what they did was they wanted to prove a theory that they had that great user experience is directly reflected in stock price, or directly reflected in revenue and profit. So what they did was they invested $50,000 in each one of these, or not each one, but in all of these companies, and watched over a year each one of those companies' stock price go up. And they concluded that great user experience is directly reflected in stock price, so they proved their theory. Now, we as Rubyists don't have a stock market. We're not talking about money, but we do have the community, and we do have Ruby Gems. We have different libraries that we can choose from when we want to do certain things. We have numbers and metrics. We have people maintaining these projects. We have a number of ways that we can determine whether or not a gem is successful or not. So one example is RSpec. RSpec became really popular because it had a great UI. Another example is, I can never say this, HTT Party is another example of a gem that was doing something similar to what some other gems did, but it sort of became popular because the UI, the user experience, was superior to some of the others. So user experience is extremely important as you're building a gem. And even beyond that, at MongoDB, arguably, MongoDB became really popular really quickly because we really focused on the developer experience. And it's known for this great user experience. We still focus on this, even as we grow. I'm on a team called the drivers team. We're about 22 people, and we support officially 12 different languages. And on this drivers team, I'm on a bigger team called the developer experience team that consists of docs, tools, and some other things. And it is our focus on this team to make sure that no matter what product you're using or what interface entry point you have to using MongoDB, it's consistent across each one of those products. And we've found that, like MongoDB, like everybody knows what MongoDB is, and it's become so popular just because we've really focused on the community in this way. Another really example of how we focus on developer experience is the shell. So for those of you who have used the MongoDB shell, what language do you use in the shell? JavaScript, right? So JavaScript is a great entry point or a great way to allow developers to interact with the database because many of us are familiar with JavaScript. And so this is one way that we were able to get so many users so quickly. So more specifically, Gem API design is UX design. So how is it UX design? Let's talk about some UX design concepts, user experience concepts. Well, first of all, obviously, you have users, right? So what do you do with your users? You're not coding in a vacuum. You have users who are consuming your code. How do you think about your users? Well, one thing is that you should really know your users. Who are these users? As I said, they could be open source users. They could be your future colleagues, your future self, your current colleagues. Who are these users, and how are they going to use your gem? How do you want them to use your gem? You need to listen in. So how do you listen in? There are so many channels through which you can find out how people are using the Ruby language and what projects people are building, what needs they have, and how your gem can fulfill those needs. Read blogs, use Twitter, talk to users, give presentations. I come to a lot of conferences. I do really enjoy giving presentations, but I also really like just listening to conversations and watching other presentations, listening to what you guys don't like, what you do like, how you're using the language, what's the future of Ruby, what do people see themselves doing with the language in the future. This is extremely important input as you maintain a gem. Get to know your users. They're people. And as you get to know your users and you build this gem, you want to establish trust with them. So what does that mean? If they're relying on your gem in their application, you want to make sure that changes you make to the software they depend on is not going to break their code. So that seems sort of obvious, right? But we have this set of principles called semantic versioning that we all preach and we say that we stick by, but I can't emphasize enough how important this is. So we had an experience once where we were exposing something we didn't mean to expose, and someone had sort of started to use it. It was supposed to be private, but it wasn't marked as private. And then we had changed it in a patch level version and broken their code, and it didn't go over so well. We didn't intentionally do that, but the user was disappointed in the gem, disappointed in us, because we had broken this contract and this trust we had with the user. Extremely important. The other way that you can get to know your users and have this sort of open communication with your users is identifying star users or super users and maintain an open communication channel with them. So, for example, a couple of weeks ago, so at MongoDB, the Ruby team is building a new driver. We call it Ruby 2.0. And we're trying, so the driver is like pretty old, it's a couple years old. And we want to rebuild it and use an architecture that's more consistent across some of the other drivers at MongoDB. And we have some customers who are very active and like to give us a lot of feedback, either positive or negative. And so this one customer a couple weeks ago had asked for a specific timeout on a socket. And we didn't provide this specific timeout. And so we were talking about this. We were trying to decide whether or not this is something we should support. But after this whole conversation was concluded, I said, actually, you know what? Like in Ruby Driver 2.0, what do you want? What kind of timeouts do you want to see in the driver? And then we just had this discussion about like what they would want. So you don't have to poll like 20,000 people or like, you know, on the order of hundreds of users. But if you just ask a couple, you'll find that even with 3 user feedback or like 5 users even, you'll have a pretty good idea of what users want. So make sure you like really maybe like identify like 3 particular people who are willing to test out your gem in a test environment or your RCs and just give you feedback as you develop and as you release. Which I skipped this, but release is also, like make sure you stick to that in your semantic versioning. Like if you're gonna add features and you release in RC1, don't continue adding features in RC2. Like stick to that really well as well. It doesn't just go for breaking people's code. Okay, so that's users. So obviously user experience involves users, get to know your users, identify star users. The second thing is concepts. So we have a number of user experience concepts that, I'm not a user experience expert, but there are a couple of them that do apply to GEM API design and development. So we're going to focus on 3 of them: consistency, simplicity, and mapping. Consistency is what you might think of as maybe like a symbol in your system or an interface element that a user interacts with that has a specific effect on the system. And every time you show that symbol or provide that thing, that interface component to a user, you want to make sure it has a similar or parallel effect on the system, if not the same effect on the system. So a great example of this is button colors. So we all know that red buttons mean danger or cancel, blue buttons mean information, grayed out buttons mean something not important or defaults, and green buttons mean success. And every time you see these buttons everywhere, you probably don't even read them, you just look at the color. And that's because these interfaces are consistent. We recognize these symbols and we know what they mean. Another interface component or user experience concept is simplicity. Simplicity is not exposing implementation details or too much information to a user. You, as the GEM designer and the GEM developer, know way more than the user. And the user doesn't need to know everything you know. You only want to expose to the user what concerns them, what concerns their code. So this is especially relevant at MongoDB as we develop the driver. There are so many little things that we know about the server that the user doesn't need to know about. We need to focus on the little things, the little knobs that the user can actually play with and that would have an effect on their own code or their own understanding of what's going on. It's actually really difficult to design something super simple to someone who only needs to know a certain amount of what you know. And mapping. So mapping is the last concept that I'm going to show through user experience design for GEM APIs. This example, I think, is really great. Mapping is where you have interface components that have effects on the system, and it's obvious what effect it has based on how you interact with the interface. And the state of the system is really obvious to the user after the user makes some change. So a great example here is a stove. So there's both a bad example and a good example. The top example shows a number of burners on a stove, and they're arranged in some fashion. And then you have all these knobs that manipulate these burners, but the knobs are in a row. So it's not obvious to a user which knob goes to which burner. And then the stove on the bottom shows a layout of burners and then knobs that are in the same exact layout. So there's a really good mapping here. This knob has an effect on this burner because I can make an association between where it's placed in the mini mapping and the greater mapping. And then it's really obvious to me when a burner turns on that the state has changed and what effect that knob has had on the system. Okay, so consistency, simplicity, and mapping. How does this relate to gem API design? What do you need to consider as you maintain or develop a new gem? We're going to talk about 3 consistency considerations, 4 simplicity suggestions, and 5 mapping mantras. And look at examples using the MongoDB Ruby driver to see how, over the course of the last year and a half, we've changed some features and developed the API to adhere to some of these user experience concepts. 3 consistency considerations. Consider consistent naming. So this might seem super obvious, but as I said before, variables are really important. People are going to look at your code and want to understand, just by looking at it, what's going on. Use consistent variable names across classes. Use consistent module names. Use consistent method names. Use consistent ops names, like option names. If you have a class that's called something, and then you create an instance of it in some other class and refer to it by the same name, or refer to it to some name that evokes what that thing is. Don't get too creative with your variable names. You want your code to be as clear as possible and consistent. Consider consistent style. So there are a number of things. Someone gave a talk this morning about linters and ways that you can run your code through some sanitization processes to figure out if your code is consistent in style. We, on the Ruby Driver 2.0, have chosen to use RubuCop. There are a number of other ones out there. This goes for spacing in hashes. This goes for method length. This goes for how you're doing argument chaining. There are a number of configurations you can do with RubuCop, but the reason we do this is so that amongst our team, which is fairly small in number, but amongst our team we have a consistent style, as well as when people want to make a contribution to our gem, they have the same style as us. And we want to make sure that over the course of time, this style stays intact and consistent, so you don't have these sort of like bits of your code that like really exude one personality over another. You want to keep it as consistent and smooth as possible across all elements of your code base. The third thing with consistency is consider consistent behavior. I think a good example of this is how you raise warnings and exceptions, or how you alert the user about something. So there are a number of behaviors that you can think about to keep consistent, but in this case, I can think of a particular example a couple weeks ago where we have, you can do a MapReduce in your replica set in MongoDB, and you can choose a particular node in that replica set to do that MapReduce on. You can't do, under some conditions, you can't do your MapReduce on the secondary. But if you say to do it on the secondary, in the past, we would just raise an exception and say, hey, you can't do it on a secondary, choose we call it read preference, choose a read preference of primary. And then we were doing something else with aggregation framework, which is similar to MapReduce, and then you can choose a secondary there, and it had a similar problem to MapReduce. And then we realized, according to spec, that we needed to actually, behind the scenes, reroute the query to the primary. And then we were like, wait a minute, this is not consistent style. We can't raise an exception for one case, and then something very similar, just raise a warning or do something sort of behind the scenes that the user's not aware of and maybe surprise them later on when they find this job is running on a node that they didn't expect. But the point here is not that whether or not you're warning the user or raising an exception, it's just that you need to be consistent with the behavior of your gem and how the user interacts with it. So those are consistency considerations. Simplicity suggestions. So as I said, simplicity, remember, it's not giving the user, overexposing implementation details to the user. It's giving the user access to certain interface components that are relevant to the user and the user's code. So first, give classes a single responsibility. We hear this all the time. I think it pretty much speaks for itself, but to give you a concrete example, in Ruby Driver 2.0, I don't know about you, but client, cluster, collection, cursor, database, errors, node, it's super clear to me what each one of those classes does, what their functions are, and how they interact with each other. You want to stick to this, because when people open up your gem, they start looking at the source code. You want them to be able to know where to go to look for certain functions, and they want to know how things sort of work together. And it gives them an idea of the architecture as well. It's really clear, and there's a lot of transparency when you keep classes having a single responsibility. Another example is I was refactoring some code recently, and along the lines of read preferences, which I mentioned before, which is where you can choose a particular node to do a certain operation in your replica set, I realized that actually I was refactoring the code having to do with the MapReduce problem, and I was looking for the code that could determine if you could do something on a secondary, and I found some code. We had this read preferences module, but I found some relevant code in a utils module as well. So single responsibility doesn't just go for classes. It goes for modules also. People are going to look for specific functions in specific modules, and you need to make sure that it's as centralized and clear as possible. This wasn't necessarily bad design. It was just an oversight when we were refactoring at some point and extracting some code out into a read preferences module. So it made more sense to put this code all in one place called read preferences, because as a user, when I look at the code base, I will look at a read preferences module for all the logic having to do with read preferences. Second thing, hide implementation details. This goes along the same lines. Don't expose all of your knowledge to the user. The user doesn't need to know all of that knowledge. Only give them access to certain things that are relevant to them. So use the protected keyword private. Only expose things to your user that they should be interacting with. I realized, though, that there's going to be a public API within your gem itself, and sometimes you may unintentionally expose something that the user could use, but the user shouldn't be using. And this is actually a case in which you need to be really careful with your documentation and make sure you say never use this method as directly to the user, and only allow your, and emphasize that it's an internal public API. Be frugal with helpers. You may feel like in the beginning that an API is really great if you abstract everything, and you provide all of these different methods to a user that are wrapping all of these underlying concepts. What you want to do instead is really think about how the user is going to be using your gem, and only provide helpers for the things that they will be doing. So an example of this in the Ruby driver is we have lots of different types of indexes in MongoDB. We have geospatial indexes, we have text indexes, we have ascending, descending, unique, goes on. Instead of providing a helper for each one of these different types of indexes in MongoDB, we've chosen to keep it simple and just say create index, and then we have a constant corresponding to the string that determines which index is which type, and then you can just use it as the user. Why do we choose to do it this way and not provide a helper for each one? Well, I don't think the number of indexes or the types of indexes we have is going to remain the same forever and ever. There are going to be indexes added over the course of time. We might need to update indexes for backwards compatibility. We're just going to have the number of methods grow and grow if we change the name of the string constant of one of the indexes. This is where something really simple like create index, and then you just do something like that. That's simple enough for a user. You don't need to over-abstract everything and provide helpers where it's not necessary. And the other thing is, this is a great exercise. Design your API first. Pretend you're the user, build a little app, and actually write some lines where you're using the gem that you're building. And then do the implementation later on. So at MongoDB, we as a drivers team, as I said, we're 12 different languages, and we talk amongst ourselves all the time, regardless of whether it's Java or Scala or Python, Ruby, Perl, PHP. We couldn't be any different in terms of what languages we use on a daily basis, but we all talk amongst ourselves, and try to make sure that this user experience of MongoDB is consistent and that the API between all of these drivers is as consistent as possible. So we have this initiative to try to take some of the commands that you can run in MongoDB that are potentially really confusing or overly complex and not super transparent to a user, and try to build these helpers around them that in reading just even the name of this helper, it is immediately apparent to the user what that thing does. So, for example, we have a command called find and modify. I only put 3 parameters here, or options here, and there are actually 7. And so, for example, new, true, what does that mean? That means that when you do a find and modify, it will do a find and get a certain number of results. Choose one of those results to either remove, manipulate, or do an upsert. There are a bunch of things that you can do. New, true means return the document after it has been modified or created or removed. You can do new, false, which obviously will return the document before it has been modified, removed, or upserted. And so in this case, like, as I said, there are 7 options you can pass to find and modify. So it doesn't really make a lot of sense to force the user to use this command and then go consult the documentation, maybe on MongoDB's site, where it lists out all the intricacies of each one of these parameters. It's much easier and much better experience for the user to provide something like update one then get. It's like really simple, and it says just in one reading what that does. So think about, like, it's sort of this nice balance between like when you want to expose implementation details or allow the user to do things as hands-on or directly as possible, and where you want to add helpers where there might be some convolution or some complexity that's just not even worth exposing to the user. So those were simplicity suggestions. Mapping mantras. So again, mapping is where you have an interface component that is very obviously related or has a direct effect on some element of the system. And you want to make sure that whenever there's a change in the system, the user gets some feedback and knows what effect that interface component has had on the system. So first of all, monkey patching is mean. Monkey patching is a bad idea. I don't think there's ever a good case for monkey patching. I don't want to embarrass the past colleague, but I think this example is too good not to share. We found in our code at some point, I'm going to breeze past this really quickly, we found a method called lock-with-hack that was really quick. Lock-with-hack that was aliased on lock in a mutex, not a good idea. So use refinements instead. We have to support back to 187, so we can't actually use refinements. So it might not be an option for you. People sometimes say use inheritance. If you find that you need to monkey patch something, maybe your design's a little off and you need to reevaluate your design. There's no quick fix or like quick answer to getting around monkey patching, but in general, if you can avoid it like the plague. 2, side effects are surprising. That sort of speaks for itself. But to give you a concrete example, if someone is passing in ops to a method that they potentially could be using over and over again, don't mutate their ops. So for example here, if I pass in ops to a MapReduce, it could, as going back to read preferences, it could say use a secondary node for this MapReduce. And if you extract or you delete one key from that hash, the reference is going to be used over and over again in future MapReduces in their own code and potentially have surprising effects to the user. So make sure you do something here like dupe the ops so you're working with the local copy. So avoid side effects that's breaking the trust that you have with your user. Requiring method chaining is impolite. Why is it impolite? Because you make your user's code look ugly. Make sure that this is a train wreck, violating the law of Demeter, whatever you want to call it. If you are not giving your users access to the right things, their code might end up looking super ugly, and you want to avoid this. You want to make sure that the API you're providing to the users allows them to work with your code in the cleanest, most elegant way possible. Informative error messages are imperative. I know I love MongoDB, blah, 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 but I think Mongoid is one of the best examples of great error messages. This is an error message, not a blog post. So user.find with a certain ID, You get the like basic error. It says errors, document not found. Then you have problem, documents not found for class user with IDs 1, 2, 3. Summary, when calling user.find with ID, blah, blah, blah. So you have this nice summary even of what happened. And then what's even better, it tells you resolution. It tells you what to do. And it gives you 2 options of what you can do. This is the best error message ever. So think about your users, like they're going to be frustrated when they get an error. You want to give them as much information as possible so they can solve the problem on their own. Because otherwise, you're going to get issues logged against your gem that you're going to have to go through and write out an answer and tell them what to do. So save yourself the time, save your users the frustration, and write nice error messages. And the last thing is documentation. So I went to a presentation recently, and someone said inline comments are a code smell. I totally disagree. I think inline comments are extremely important. In particular, if you're writing a gem against something like a database, for example, that might have some obscurities or like some weird things about it that you need to write some fancy code around, or something that might not be totally obvious to a user looking at the code. If you find yourself writing lines of code that seem sort of confusing to you, you have to stop and think about it really hard before you write it, write an inline comment for anybody looking at their code. It might even be you in a couple of weeks when you forget what you did. So for example, the server, the MongoDB server, a couple of weeks ago decided to create this option called digest password. And what digest password is in the context of authentication is tells the server that you need to digest the password because I haven't on my end. So the driver has to, we digest the password driver side, but then we set this field saying digest password false. Because when it's sent to the server, it's telling the server that you shouldn't digest the password. But a user looking at this code is going to see, OK, digest password equals false. That doesn't seem to make any sense at all. So my colleague who did a code review kindly told me, why don't you just put an inline comment here so that someone looking at it is not like, why are you digesting the password and then setting digest password to false? So inline comments are great. Not like paragraphs like the Mongoid exception or the Mongoid exception summary, but make sure that inline comments are just little notes for yourself that are super clear. Think about them actually as notes to yourself. Make them super clear because other users will find them really useful. Documentation tools, we use Yard. It's really great. I think the documentation looks great. It's really easy to use. All the tags are wonderful. READMEs should be short and sweet. They should not be guides. They should not be tutorials. They should be sort of like an abstract for your gem. So someone who is looking to evaluate your gem, just quickly decide if it fulfills the needs that they have, if it's something that they want to use, if they like the API. Make sure you put these things in your README, because this is what people are going to look at quickly when they want to decide whether or not to use your gem. So those were mapping mantras. We talked about consistency, we talked about simplicity, and we talked about mapping. These are user experience concepts that are super relevant to gem API design, as well as software design, whether you're a gem author or user. And if you haven't authored a gem or had the opportunity to maintain a gem, and you just want to try it out, there's a blog post by Daniel Dubrovkin where it's called Your First Ruby Gem, and it's really excellent. He goes through sort of this checklist of things that you have to do as you're building a gem, like check the name, create a README, add a license, a gem file. It's really useful for if you just want to even try it out personally on your own time and not even share it with anybody. It's a great resource for getting started. So think like a UX designer. It's not just about writing code in a vacuum. And I want to end on a quote from Golden Gate Ruby Conference. James Edward Gray II gave a phenomenal presentation about what it's like being a programmer and his own personal experience being a programmer. And he said, programming is easy. Anybody can program. But to be a programmer, that's what gets you to the next level. So get social, get to know your users, and talk to me about the Ruby driver.